Solving systems of linear equations using augmented matrices. Here we have a system 2x sub 1 minus 3x sub 2 is equal to 5, and x sub 1 plus 2x sub 2 is equal to negative 3. Well, we can also think of these in terms of x and y. X and y. So we can think of that in terms of x and y. As well. So if you have equations that are using the variables x and y, the same process will follow. Our goal is to, again, transform this into an augmented matrix, which we do here, where we take the coefficients from each one of the variables and the constants after our equal sign. So here we have 2, negative 3, 1, 2, and negative 3, all taken from the above system. Our goal is to transform the matrix into 1, 0, 0, 1. And in terms of your solution, you have either your x sub 1, x sub 2, or your, of course, x and y would be the solution in terms of x comma y. Some of the things that we can do to transform our matrix into 1, 0, 0, 1 is that the rows can, we can exchange rows. If we have one value that can be interchanged to make it into a 0 or a 1, we can interchange rows in that way. We can also multiply rows by non-zero constants. And another thing that we can do is constant multiples of a row can be added to another row. So the first thing that we can do to start transforming this matrix is to interchange row 1 and row 2, because originally row 1 had a 1, where if we interchange it, we can move that 1 up here. We have to move the entire row, so we can interchange rows, and then our new matrix would look like this here, from this here to this here, interchanging the rows. And another thing that we can do to get some of the results that we want is we always want to look at the equation, at the matrix, and see, well, I need this to be a 0, I need that to be a 1, I need that to be a 0. So what we can do is we can multiply row 1 by 2, by negative 2, and then add add that result to row 2 and replace row 2 with that. So multiplying row 1 by a negative 2 will get us a 0 when we add the two rows together. This is the result of multiplying row 1 by a negative 2. Now, if we add that to the original row 2, we'll get a new matrix that has the 0 in row 2 that we want. So 0, negative 7, and 11 as a result of adding the two together. Now, row 1 does not change. Row 1 is going to stay like it is. We're just going to replace row 2 with the new result of adding the two together after we have multiplied row 1 by a negative 2. So our new matrix is what we have here. So we have a 1 and a 0 in the place that we want. We want to get a 0 there and a 1 here at this point. So the next thing that we can do is multiply row 2 by negative 1, 7. and then replace row 2 with those results so that we can get a 1 right here. So multiplying row 2 by negative 1, 7 will produce the new row 2 that we see here. So now our new matrix is as follows. We need a 0 to get to this. We need to replace this with a 0. So one of the ways that we can do that is by multiplying negative 2 to row 2 and then adding it to row 1 and replacing row 1 with those results. So negative 2 times row 1 gives us this result here, 0, negative 2, 22 over 7. And then we're going to add that to row 1. So 1 plus 0, negative 2 minus 0. We get the 0 that we want for row 1. And we're going to replace this in our row 1. So now our new matrix is 1, 0, 1 7th, and we have a 0, 1, and 22 over 7, row 2. We have what we wanted. We transformed this matrix. Our solution to this system is 1 7th for x and 22 over 7 for y.